In this video, we are going to learn about one of the very important topic in mathematics. So we're going to talk about solving trigonometric equations. So what is a trigonometric equation? Trigonometric equation is an equation that contains at least one trigonometric function. So which is an equation which has at least one trigonometric function. For example, these three are trigonometric equations. So you can see square root 3 tan theta minus 1 equal to 3 sine square theta minus sine theta minus 4 equals 0, or 2 secant square theta equal 4. So we're going to talk about how to solve these equations and more in few minutes. So so solving a trigonometric equation is to find the solution set. So when we say solving the trigonometric equations, means you try to find the solution sets. That means you try to find all the solutions, all the solutions. So there's one major difference between trigonometric equations and other equations. We know that trigonometric equations are periodic functions. So trigonometric functions are periodic. Since the trigonometric functions are periodic, so there are infinitely many solutions for certain equations. So that's like a very different situation compared to polynomials and other equations. We know that in polynomials, if a degree n polynomial, there can be at most n solutions, but that's not like this here. So when you have trigonometric equations, you have infinitely many solutions for certain problems depending on the value that we're gonna pick. So it's in general. So let's look at a certain situation. Let's say we have a general equation, t theta equal c, where t theta is like any trigonometric functions. So t theta is any trigonometric function. C is any constant. So, for example, let's look at this situation. We have sine theta equals c. So that means sine theta equal a constant. So we know that the sine graph have this format. So it's gonna start with the 0. So let's say we just look at one period. So 0, pi, and 2 pi, and then we know that that's gonna go with two specific values, 1 and negative 1. Now let's see several situations. For example, let's say you're gonna pick a c value 1/2. So if you pick a c value 1/2, that means we're gonna find for what theta this function equal to 1/2. So for example, what in geometry what we can do is we can draw a line up through 1/2. So we can draw a line through 1/2 and then look for what values gonna give you that value. You can see, for example, in this case, so we can map that value back to the x variable, So when you do that, you can see, so there's a one value here, and there's also another value there. So you can see in this special value 1/2, there are two values. So you know that from the sine function. So for example, if you have, so I'm going to call the first value is x1 and the second value is x2. So you can actually find those two values. For example, we know that the x1 is simply pi over 6, or in degrees it is 30 degrees. And then there's another value x2 which is 150. So you know those two values. So that means even like if you pick like 1/2, you can see there are two values there. So for example, let's see like another value. So I'm gonna pick, for example, let's say 1. So if you pick 1, so you can see in this case there's only one value. So in this case you don't have two values. You can see there's only one value. So that's the value. I'm gonna call x3 in this one period. So you can consider just one period from 0 to 2 pi, and you can see that there's only one value in this case. So that means if you pick c as 1, so this is the c equal 1 situation. This is c equal 1/2 situation. So for c equal 1/2, you have two values. For c equal 1, you have one value. And also the same thing, like for example, let's say you pick negative 1/2. So if you pick negative 1/2, and you can see it's again cuts at more than 1 point. And then those two values gonna maps to two values. So there's a one value here, and also there's another value over there. So there are two values again. Um, And then let's say we're gonna pick a value like up here, like 3, like 2, let's say in this case 2. So if you pick a value 2, and you can see that this graph never crossed this value. So that means if you pick a value 2, what happened? There are no solutions. So that means there are several cases here. So you can see if you have 1/2, you have 2 values. If you pick c equal 1, you have 1 value. If you pick like c equal 2, you can see that there are no values. So that means anything, those 3 situations can happen in a situation like this, especially in one period 0 to 2 pi. And then since it is periodic, what we can do is simply adding 2 pi, you can generate, adding or subtracting multiples of 2 pi, you can generate all the other values. So that is what we're going to do in general. We're going to find the values from 0 to 2 pi or 0 to 360 in degrees, and then we're going to add multiples of 2 pi or multiples of 360 degrees to find all the other values. So that's what we do in general. So we can summarize these results like this. So you can see that in most of the trigonometric equations, so there are two solutions. There are two solutions in 0 to pi or 0 to or you can say 0 to 360, depending on whether you want to do it in degrees or you want to do it in radian. And it can be solved in either radian or degrees, depending on the need. And also adding either multiples of 2 pi or 360, again depending on radian degrees, you can find all the solutions. Here multiple means integer multiples. You have to be careful with that. Integer multiples, not any multiple. Integer multiples, adding integer multiples of 2 pi or 360, you can find all the solutions. So a general problem has 5 steps. So let's look at those 2 steps. So what we normally do is, if we get a problem like that, first thing what we do is we factor. And then after we factor, we're going to set each factor equal to 0. And after that, we can isolate. So we're going to set each factor equal to 0 and isolate the trigonometric functions. So sometimes what happen is those trigonometric functions are like, we normally try to bring it to sine, cosine and tangent. If it is not sine, cosine, tangent, we try to rewrite. So let's say you have secant or cosecant, secant or cotangent. What we're trying to do is we can convert them into sine, cosine, tan. So that's what we do at the beginning, but this is not a must. But this can make it easy to solve if you are familiar with those values. But you can still simply solve using cosecant or secant, but we normally don't do that. We just try to bring it to sine, cosine, tangent before we solve. So so the third step is, after we isolate the term, we're going to find the reference angle. We're going to find the reference angle, because reference angle method is the easiest and straightforward method. So we're going to find the reference angle after we isolate the trigonometric function. And then what we're going to do, we're going to find the principal values. So what are the principal values? And you can see in the discussion earlier, when you draw the line, it's going to cut at 2 points. You're gonna find 2 values in the domain that going to give you the value you need. I mean, there are 2 solutions, or sometimes there are 1 solutions. Those are in 0 to 2 pi. Those are we normally call principal values. So you'll find the principal values first, and after you find the principal values, what you can do, you just add the multiples of like multiple of 2 pi, or you will simply add 2 pi k or 360k, where k is an integer, to find the general solution. So these are the 5 steps method to solve a general trigonometric equation. Um, Also, there's a major help or tool that we normally use. So this is the general formula. So like, let's say for example, if you have f theta equal like, you're gonna what we normally do, like if you have function, trigonometric functions, we normally write this one as, so you can always write this one as plus or minus f the reference angles. That's the technique what we normally use um, here. And you can see that the sign, we're gonna find using the ASTC argument, so that we discussed earlier. So ASTC argument gonna give you the sign. And then to find the function, trigonometric function value at the reference angle, we're going to use the table on the right. So this part simply coming from the table. And also this table is the common trigonometric values that we normally use. And then you can see that so there are certain patterns here, like for example, if you if you reverse the values in the sine, you're going to get the values in the cosine. That's one of the common practice. And also you can see that to get the sine values, what you normally do is you're going to write 0, 1, 2, 3, and 4. And then what we can do, we can divide everyone by 4. We divide each number by 4. So write 0 to 4, divide by 4, and take the square root. Once you do that, you can see that these are the values in the sine table. So you can see these are exactly the values in the sine table from 0 to 90 degrees. And then to get the cosine values, you reverse the order. So this is the trick you can use. You write 0 to 1, 2, 3, 4, and then divide by 4 and take the square root. And then to find the values for multiples of pi over 2, to find the values of multiple of pi over 2, we use the unit circle. So use the unit circle. So that's what those are the common things that we use. So unit circle means the circle with radius 1. And then you can see that the cosine is the x coordinate, sine is the y coordinate, tan is the you're going to divide the quotient of the y coordinate or x coordinate if it is defined. So you can see, you can find all the values using this. So these are the things that you need to remember, and you can see using these you can easily solve any problem of this type. So let's also look at the quadrant. What happened in the quadrant? So to find the reference angle, so let's say, so these are the reference angles. So the question is, if you know the reference angle, how to find the angle? So for example, so you can see that in the first quadrant, so the angle is simply theta r, and then you can add multiples of 2 pi. But here just I'm writing the principal values, and then here you can see the principal value is simply so this is the 0, and then this is we normally write this as pi. This is also pi. This is 2 pi. So you can see for at this time in the quadrant 2, your value is simply theta equal pi minus the reference angle. That's what happened for the quadrant 2. For the quadrant 3, you can see that theta is simply pi plus the reference angle for the quadrant 3, because pi and a little bit more than like pi plus theta r, the reference angle. And for the quadrant 4, you can see it is 2 pi minus the reference angle. So those are the three cases, and you can see that we're going to use this a lot depending on the situation. And these are the principal values. To get the other values, what we normally do, we're going to add multiples of 2 pi or multiples of 360 depending on the radian or degrees that we work with. So let's try to look at several problems now. So as the first problem, we're going to solve sine theta equal 1/2. So let's look at the corresponding graph in this case, and you can understand what's really going on here. So the sine graph, we're gonna look at just the first period. So this is the sine graph, and this is the same situation we discussed at the beginning. So we can see that this is 0, and then pi and 2 pi, the first period. And then we're going to look at the values. So we're going to draw the line 1/2. And then you can see there are two values. There's a one value here, the other value there. So there are two values. So what we are going to do is we're going to find the reference angle first. And then also you can see that this is sine and this is positive. So that means the angle should be either in the first quadrant or the second quadrant due to the ASTC argument. So if you write it back, so this is ASTC. That means it is positive in the first quadrant, or sine is positive in the first quadrant or the second quadrant. And then you can clearly see that that's exactly what happened. So what we normally do is we're going to find the So if you get a problem like that, what we normally do is we're going to find the reference angle first. So that means theta r. So what is theta r? Theta r is, we ignore the sine. We can write sine inverse 1/2. That's how we write. And then from the common table, we know that the for theta equal pi over 6, we get 1/2. So I mean that's the reference angle. Since you know the reference angle, that means your values, one value is pi over 6. To find the other value, you can see, to get the other value, what we need to do is you're going to subtract, because you can see those gaps are the same. So these two gaps are the same. You can see this gap and that gap are the same. That means you have to subtract this value. So that means this, to find the second value, it should be pi minus pi over 6, because the gaps are the same. And also we discussed this in just a minute ago. If you look at the 4 quadrant, in the second, if you need to find a value in the second quadrant, what we normally do is pi minus the reference angle. Okay, so so that's exactly what happened in this case. So we can also see this in a in the quadrant setting. So these are the quadrant, and then you can see, so that is in the first quadrant. So this is the value pi over 6, and this is opposite over hypotenuse. And then the value in the second quadrant, you can draw it like that. So you can see it's also positive. That means this is y coordinate is positive, and then this is the hypotenuse. So we have that, and then you can see this is again the same reference angle pi over 6. So to find the angle, what we do, so that's the angle we are looking for. To find the angle, what we do, it is pi minus, because this angle is pi, straight angle. So we're going to pi minus pi over 6. So that means you can write the solutions like this. So we can say theta is pi over 6, that's the one in the first quadrant, or to find the value in the second quadrant, or theta equal pi minus the reference angle. That's always the case. So that means it is pi minus pi over 6. Reference angle does not change. So if you simplify, you can see this is simply 5 pi over 6, taking the common denominator. So this is in the in 0 to 2 pi. There are no other values. Those are the only values you're going to get from 0 to pi. Now, what we can do, adding multiples of 2 pi, adding multiples of 2 pi, we get all the solutions. So that means we can say theta equal pi over 6 plus 2 pi k. When you add that, you get all the other values, because you can see it's periodic. That means if you add a 2 pi, you get the same sign. Or you can see the other value is 5 pi over 6 plus 2 pi k. So you can see where k is an integer. Where k is an integer. So it's an integer multiple of 2 pi. That's how we did. We add integer multiple of 2 pi. So this can give you all the solutions of this equation. So this is how you solve the first equation. So let's look at the next one. As the next problem, we can solve cosine theta equal negative square root 3 over 2. And you can see that square root 3 over 2 is a common value that you can find on the table. And also we see that there's a negative sign here. So that means according to ASTC, this angle has to be in either in the second quadrant or the third quadrant. And that means if you know the reference angle, one angle has to be pi minus a theta r, the other one has to be pi plus theta r. So that means your goal is to find the reference angle first. So to find the reference angle, what we're going to do, we're going to ignore the negative sign, and we're going to say theta r is equal to cosine inverse square root 3 over 2. This is what we always do. We ignore the negative sign and find it. So this is simply coming from the table. So using the table, and you can see that this value is a cosine pi over 3. So is cosine inverse square root 3 over 2. That means this is simply pi over 6. So that is the reference angle. So once you know the reference angle, then you can draw the situation. This is like optional, but it's going to clear what's going on here. So so this is the second quadrant, and then that's the perpendicular, and this is pi over 6. That's the reference angle. So that means this is the first theta 1, and then for the third quadrant, and you can see the reference angle is still the same, so it doesn't change. So this is again pi over 6. So this is the other angle, so you can write it like this. That's the second angle. So so in this case you can write theta 1, which is simply pi minus the reference angle. So that means pi minus pi over 6. So taking the common denominator, multiplying by 6 and 6, top and bottom, you can get simply 5 pi minus 6 as the first angle. For the second angle, what we're going to do, it is pi plus the reference angle. So this is again pi plus pi over 6. Again multiplied by 6 and 6, you're going to get, this is 7 pi over 6. So those are the two principal angles. So that means the solutions are, so you can simply write theta equal, the first one is, so you can see that it is 5 pi over 6 plus 2 pi k, comma, the other one is 7 pi over 6 plus 2 pi k, where k is an integer. So you can write it like that. K belongs to set of integers. So that is how you write the, how you solve the equation. So let's go to the next one. As the next one, we're going to solve this problem, and we have square root 3 cotangent theta plus 2 equal 1. So there are a few things that we need to focus on, and you can see that this is not sine, cosine, or tangent. That means it would be better to convert this into one of those. That's one thing. And also, since we solved the first two problems using radian, we're going to solve this problem in degree. It's not a must, but let's see how we can solve a problem in degrees. So we're going to see two things now. So we can start with the problem, and we can see we have square root 3 cotangent theta plus 2 equal 1. So we can isolate the cotangent term first. So to do that, first we move 2 to the other side, and then we're going to divide by square root 3. So we're going to move the 2 to the other side. So that means it's going to be 1 minus 2. That means it's going to be negative 1. And then we're going to divide by square root 3. So that means cotangent theta equal negative 1 over square root 3. So, and then we know that one of the fact, the tan theta is 1 over cotangent theta, and then cotangent theta is 1 over tan theta. That means if you flip this equation up, if you make it upside down, you're gonna get the, you can make this tangent. So we're gonna flip this. So that means once you flip it, you can write this one as tan theta on this side, and if you flip this one, this is gonna be simply negative square root 3. And then you can see that this is something familiar because it's tangent. So now what we're gonna do, we're gonna solve this problem as a tangent problem. So now we have tan, and then from the ASTC, and you can see it's a tan problem but have a negative sign. So that means tan negative means it has to be in the either in the second quadrant or the fourth quadrant. So so knowing that, then we know how to write the two angles. So the next step now would be to find what is the reference angle. So you can find the reference angle. So theta r, that's a reference angle, which is simply ignoring So we just ignore the sign, we only pick the number here. So you can see this is simply tan inverse, just the number without the sign. And then you can see this is simply coming from the table. So tan inverse is square root 3 over 2. That means it is simply pi over 3. So that is the reference angle. But since we deal with degrees, so you can see instead of writing radian, you can write this the degree value. So let's say the degree 60. Now, since you know the reference angle, and then since you know the two quadrant, we can write the solution now. So that means theta has to be the since the second quadrant, it is be 180 minus 60. That's one in the second quadrant. Or theta has to be, since the fourth quadrant, it is 360 minus 60. That's the reference angle. So we subtract the reference angle in this case. So this is in the interval 0 to 360. 360. So, and if you solve, if you simplify, you're going to get 120 here, and then O, you're going to get theta equal 300 as the two angles. So now we can find the general solution. So the general solution, the general solution, you can write as theta equal 120 plus 360 K, or the next one is 300 plus 360 K, where K is an integer. So you can write it like that. So that's how you solve a problem using degrees. So here we add multiples of 360. So let's look at the next problem. So next we have 3 cosine x equal minus 1, and we're going to solve this problem in both in radian and degrees. So we can isolate the cosine term. That's the first step. So let's isolate that. So we have a 3 cosine x equal negative 1. That means cosine x equal negative 1/3. And you will see that this value is not a common value in the cosine table. So that means what we can do, we can use a calculator to find the values. Like we can do approximations. You can find exact values. We can find the approximate values. So and also we notice that this is cosine and a negative. So cosine negative means it should be either in the second quadrant or the third quadrant. That we notice that. So to find the reference angle, what we can do, we can ignore the negative sign. So the reference angle theta r, we normally call theta r, is simply cosine inverse 1/3. We ignore the negative sign and just use the positive value for that. And then what we can do, we can find them both in the radian and degrees. So you have to be careful, since if the value is small, try to write at least 3 decimal places. Otherwise, what will happen when you convert, you get a large error, and your values may not be accurate. So so we're gonna write the value in radian mode. So like when you use a calculator, make sure that you turn the mode, you change the mode to the radian mode, and you change the mode to radian, and then you find the cosine inverse 1/3. So you should get 1.231 if you round to 3 decimal places. So this is in radian. Or if you change the mode to the degree, and then if you find the value, you're going to see that you're going to get 70.53. Since this is a large value, we just write only 2 decimal places. So this is in degrees. So that's the difference. Here for the radian, we write 3 decimal places because the values are small, and for the degrees, we write only 2 decimal places because the values are large. So that's the difference. So you always need to think about that when you solve problems like that. Otherwise, if it's a multiple choice problem, you will get wrong answers if you try to convert. Okay, now let's try to do this in the degree form, in the radian form first, and see what's going to happen. So these are in the second and third quadrant. So in radian, so in radian, you can have the two solutions x. So in the second quadrant, it has to be pi minus the reference angle. So that means it is pi means 3.142 up to 3 decimal places minus your value is 1.231. That's the first value. This, if you simplify, you're gonna get roughly 1.911. And then actually I'm gonna write it here. Yes, it's 1.911. Or x equal for the third quadrant, it is pi plus theta r. So that means 3.142 plus 1.231. And if you simplify, you're going to get 4.373. Okay, now what we can do, so this is the these are the principal values. So what we can do, we can add multiples of 2 pi to find the general solution. So in degree, we have, so this in degree we can write this one as x equal, in the second quadrant it is 180 minus 7053, so which simplifies to 109.47. Or and then the other one is x equal 180 plus 70.53, so which is 250.53. So these are approximate values. These are not exact values, these are approximate values. So the general solution, in radian, you can write this one as x equal 1.911 plus 2 pi k, or x equal 4.373 plus 2 pi k. In degrees, you can write x equal 109.47 degrees plus 360 k, or x equal 250.53 plus 360 k, where k is an integer. Okay, so this is how you solve a problem where you do not find the reference angle in the table. So we just use a calculator and approximate. You want to make sure that when you do in radian, if the values are small, make sure that you have at least 3 decimal places. But if the values are large, 2 decimal places are enough. So let's look at the next problem. So next we have 2 sine squared theta plus sine theta minus 1 equals 0 in the interval 0 to 2 pi. So we only find the principal values. So you can see that this problem is slightly different from the previous one. So since you cannot isolate the sine terms first, what we normally do is we're going to factor. So that's the first step. So that means we can look at the corresponding algebraic equation. So if you look at the algebraic equation, this looks like 2x squared plus x minus 1 equals 0. And then we know how to solve a problem like that. We can look at the factors. So you're going to look at the product. We're going to multiply these two, so you can get -2. That means you're going to think of factors that's going to give you the product -2 and sum 1. So that means you can see that the two numbers are 2 and -1. Those are two numbers. That means we can directly write the factors. So that means 2x squared. So that means it's going to be, one has to be 2x, the other one has to be x, and then the question is how to get the other numbers. So you can see you're going to divide we're going to divide the 2 by 2, so this should be +1, and then we can divide -1 by 1 because there's in front of 1. That means this can be -1. That's how we get the two numbers there. So that's the factorization. So it's 2x minus 1, x plus 1. That means here x is acting as sine theta. So because we have this factorization, you can simply write this one as 2 sine theta minus 1. That's the first factor. The other factor is x plus 1. That means sine theta plus 1 equals 0. So that's what happened. So after we get the factorization, what we can do is we're going to set each factor equal to 0. So that means for the first one, you have 2 sine theta minus 1 equals 0, or sine theta plus 1 equals 0. And from the first one, you can see that if you isolate the sine term, you can see sine theta is bring 1 to the other side, divide by 2, 1/2, or here we're going to get sine theta equals -1. So -1 is one of the extreme values. So when you have extreme value, what we normally do is we can look at the graph. So if you look at the graph, and you can see that, so it's a 1, -1, and 0. So you can see that the values that you get -1 is, so that's -1 and 1, and you can see this value is 3 pi over 2. So 3 times, so it's a 3 pi over 2. So that's the only value. You can see there's only one value here. There's only one value. So you can get that values from the graph. So we can use the graph even you have extreme values. What are the extreme values? Are the zeros and 1 or -1. So that means for the second equation, you can have the solution. It has to be, there's only one solution. So is theta equal 3 pi over 2. For the second one, we use do it as before. So we're going to find the reference angle. So the reference angle theta r, which is sine inverse 1/2. So that means sine 1/2 means it's a pi over 6, and this is positive. So since this is positive, and you can see that it has to be on the either on the first quadrant or the second quadrant. So that means the two values you can see theta equal the first value is 1 in the first quadrant, pi over 6, and then the other value is theta equal pi minus pi over 6. So that's from the second quadrant, which is 5 pi over 6. So those are the principal values. So now so we have all three values. So we have one value from the second equation, and we have two values from the first equation. I mean, we can combine them. We normally write them in the increasing order. So that means theta equal pi over 6 as smallest value, and the next one is 5 pi over 6, or 3 pi over 2 in 0 to 2 pi. But if in the general solutions, we simply add the multiples of 2 pi. So that's how we solve the problem. So let's look at one more. So we have solved square root 3 tan 2 theta equal 1. You can see that this problem is different from all the previous problems because we have 2 theta here, not theta. So that means since we have 2 theta, we want to think about what is the actual range we are looking for, because we know that theta has to be in 0 to pi. Then the 2 theta, that means you multiply by 2, is in 0 to 4 pi. So that means we first try to solve the equation for 2 theta in the range 0 to 4 pi. And then after we do that, then we're gonna divide by 2 and try to find all the solutions in the range 0 to 2 pi. So that means this problem is completely different from the ones we did earlier. So the answer, so let's write this argument. If the theta is in the interval 0 to 2 pi, then just multiply by 2, then 2 theta is in the interval 0 to 4 pi. 0 to 2 theta, 0 to 4 pi. So that's we know this. So we just multiply by 2 both sides. When you multiply by 2, you get that. So that means what we're trying to do now is we're going to solve this equation for 2 theta, not theta, but 2 theta. That's how we do. So we just do this as before. So we have square root 3 tan theta, tan 2 theta equals 1. So that means tan 2 theta equals 1 over square root 3. So this is like a regular problem for 2 theta. And then you can see that again, so this is a tan and positive. So that means this angle has to be either in the first quadrant or the third quadrant. So the first we got the reference angle. So the reference angle theta r, which is tan inverse 1 over square root 3. So this is simply coming from the table. According to the table, this has to be pi over 6. So the angle is pi over 6 or 30 degrees. Since we know this, then we can find the two angles here. Actually, it's not two angles because you can see we need to find all the angles from 0 to 4 pi. 0 to 4 pi. So to do that, so we can write, so then the 2 theta is pi over 6. That's the first one. And then if we add pi, so it's a pi, so the second angle is, actually you can write it like that. So the second angle is simply pi plus the reference angle. That's the one in the third quadrant. And then what we're going to do, we're going to add 2 pi to these two to get the other two angles, because if you go another cycle you get the other angle. So that means the next one is pi over 6 plus 2 pi, you add one full cycle, and then the next one is pi plus theta r again plus 2 pi. So those are the angles that you can find from 0 to 4 pi, because you got one more cycle. That's that's why I add 2 pi. So if you had like a 3 theta here, then we're gonna go 2 more. We're gonna get 2 more. So now if you simplify these, so the angles are gonna be pi over 6. So this one is pi plus pi over 6, and the next one is pi over 6 plus 2 pi, and then we have pi plus pi over 6 plus 2 pi. So in this case, actually, you can write this one as pi over 6 plus 3 pi. So that's the easy way to write it. So you can see pi over 6 plus 3 pi. So if you simplify, and you're going to get the angles pi over 6. That's the first one. And this is 7 pi over 6. And then we have here 6 times 2. 6 times 2, we have 6. And 6 times 2 is 12. Plus 1, so 13 pi. So we have 13 pi over 6. And the other one is 6 times 3, 18. Plus 1, so it's a 19 pi over 6. So these are the values. So this is in 0 to 4 pi. But what we need, we're looking for theta. That means we're going to divide this one by 2. So that means your final solution you can write like this. So we can say dividing by 2, we can write theta has to be pi over 12, and then 7 pi over 12, and then 13 pi over 12, or the final one is 19 pi over 12. So in, you can see this is again in 0 to 2 pi because we divide by 2. And if you need the general solution, you can add multiples of 2 pi k. So you can say if you need the general solution, we don't need that, but I just write the general solution. So the general solutions are, you can say theta equal pi or 12 plus 2 pi k, and then 7 pi over 12 plus 2 pi k, and then 13 pi over 12 plus 2 pi k, and say, oh, finally you have 19 pi over 12 plus 2 pi k, where k is an integer. So you can see this problem is slightly different from the previous problem because you have a 2 theta at the beginning. So what we did, we multiply the range, because we normally know that theta has to be from 0 to 2 pi. So because of that, the 2 theta is in the interval 0 to 4 pi multiplied by 2. And then we solve all the solutions in that interval, and then we divide at the end, we divide by 2 to find the solutions there. So let's do one last problem, just to cover all the different type of problems. So let's do the last one. So as the last problem, we have 2 secant theta plus 1 equals 0. So this is a secant problem. So it would be better to convert to sine, cosine, or tangent. So we can start with 2 secant theta plus 1 equals 0. So that means secant theta equal -1 divided by 2. And then if you convert this into cosine, you know that we can flip over, because we know that the cosecant theta is 1 over secant theta, and the secant theta is 1 over cosine theta. So that means we can flip over. Once you flip over, you can say this is cosine theta equal -2. But we know that so since cosine is always in between 1 and -1, there is no possible theta that's going to give you this value. So that means since cosine theta is in between -1 and 1, there are no solutions. There are no solutions. There are no solutions for this problem. So this is how you solve this problem. There are situations where you cannot find any solutions. So this video covers all type of different problems that you need to know. And in another video, we're gonna do like simple solving more problems. So you can look at that video. We're gonna call this practice problems for this one. Thank you.